Hello, ladies and gentlemen. Welcome back to math. Today, we're going to continue working on trigonometric, okay, angles. Remember last class we were learning about triangles, how to label them, your hypotenuse, your adjacent, and your opposite, okay? Opposite and adjacent go depending on where theta is, okay? Obviously, always your hypotenuse is across from your 90-degree angle, your right angle, in other words. So, before we get started today, our objective, okay? Our objective today, we are dealing with x and y, okay? X, y, and then r, which is radius. We are still dealing with sine. We're also going to deal with this opposite, okay? Cosecant. We're going to deal with cosine, secant, which is the opposite of cosine, and tangent, and its opposite, cotangent. Okay? You guys already know how to label these. These on the other side are new, but they're just the inverse. Okay? So let's get started on today's concept. Alright, so you guys can see I have the one from last class on the side here. Okay? We're kind of doing the same thing. The only difference is we have to create that extra triangle, okay, that right triangle. You're still using sine, cosine, and tangent. You're also using the opposites, okay? You're still doing opposite, hypotenuse, and adjacent, okay? The only difference now is you're dealing with x, y, and r, okay? I will say this. Y is your opposite. So if we had to redo one, we will draw it. If theta was on C, okay, let's say this is A, this is B. Opposite would be your Y. Your adjacent would be your X, okay? And your hypotenuse would be your R, okay? It kind of looks familiar. Think of a graph, okay? When you graph any line or triangle or anything on a graph, up and down is your y-axis, horizontally is your x-axis, okay? The line in between, your hypotenuse, is your radius, okay? Now, again, we're dealing with x and y as your coordinate, okay? And we're dealing with the radius. In order to find the radius, you have to do an equation known as radius equal radical x squared plus y squared. Okay, that is the equation to find your radical. For example, if I have a graph and we have a point, okay, that is at let's say 3 on the x, 2 on the y, okay? We always start at the origin, which is the center, and we make our line, okay? From the origin. Remember, the point is at 3, comma 2. 3 is your x-axis, 2 is your y, okay? So let's label it in there. X and y, okay? If you look at this line, if you connect a pretend line in there, okay? that goes from our 3. Okay? Doesn't this look like a right triangle if we do a little angle there? It does, right? So 3 comma 2 is telling us that there's 3 on our x, 2 on our y. Okay? What we're trying to figure out right now is our radius. So we're going to use the equation for radius. Okay? Theta is always closest to the origin. Okay? In this case, theta is here. Okay? So let's find the radius. We have r equals x, in this case is 3, so 3 squared, plus y, which is 2 squared. Okay, so r equals radical of 3 times 3 is 9. Okay, plus 2 times 2, which is 4. Okay, so technically our answer is radius is the radical of 9 plus 4. So we have 9, 10, 11, 12, 13. Okay? So our answer is radical 13. Okay? So that's our radius. Our radius is radical of 13. Now that we have all 3 of our sides, okay? We have our x-axis, our y-axis, and our radius. We can actually plug it in to solve for theta, okay? Using sine, cosine, and tangent. Remember, y is your opposite, okay? So y over our hypotenuse, which in this case is r, okay? Then we have cosine, which is adjacent, which is x over r. And finally, for tangent, we're going to have opposite again, which is y over adjacent, which is x. Okay? Now that we know what they are translated into, we can actually plug it in. So we have sine equals y, okay, because remember, we need to get y first. So in this case, y is 2 over r, okay, which r is radical of 13. But since we cannot have a radical on the bottom, we have to multiply by radical of 13. Okay? The reason why is to get rid of the radical. So technically this becomes sine equals 2 times radical of 13, which is 2 radical of 13, over radical of 13 times radical of 13. I will say this, okay? Since you have 2 of them, all you have to do is bring one out. Think of pairs. Since you have a pair of 13s, all you have to do is bring out the 13. Okay? So we have one answer. But wait, we have to do 2 more answers plus the opposite. So now I'm going to do the opposite first. So we have sine, which is the opposite is cosine, which is, let's use purple, cosine, okay? CSC equals think of the same thing we did. We did y over r. For the opposite, we flip them. We have r on top, y on the bottom. Okay, so this time it's r, which is radical of 13, over y, which is 2. Since we really don't have a radical at the bottom, that's it. Okay? I will say this, guys. If you want to actually solve for that theta, all you have to do is plug it into the calculator to get your answer. Okay? Our next one is cosine equals x over r. Again, this time we have 3 for x. And then we have r, which is radical of 13, which again, we cannot have a radical at the bottom. So what we're going to do is, we're going to multiply by radical of 13. That means that we have cosine equals 3 radical of 13 over 13. Okay? That's one more answer. But remember, now we have to do the opposite of cosine, which is secant. So let's go with purple. So we have secant, which again is the opposite. Notice how we have 3 over radical of 13. We flip them. So we have radical of 13 over 3. Okay? We're almost done. We need 2 more to go. Okay? We need tangent. So for tangent, we'll do it over here. For tangent, we have y over x. So y, which is 2, over x, which is 3. Because remember, 3 over 2. Since that has no radical on the bottom, that is the answer. Okay? And cotangent, we just flip the 2/3 to make it 3 over 2. Okay? Again, if we were to find theta, now that we have all our answers, all we have to do is, if we're looking for sine, press the sign button on your calculator, type in 2 radical of 13 over 13 to get your degree. Okay, that should give us the degree of theta. Okay, but the main point of today's concept is I want you guys to get the practice of knowing how to plug it in for sine, cosine, and tangent, and its inverses, okay, using y, r, and x. All right, so make sure you write the notes down. Okay. All right. So I'm going to give you a few points. Okay. You guys have to do your graph okay. So you guys can get the practice. All right, guys. So your point is, or your points, one of them is 8 and 4. Okay. Remember, you have your x, which is the 8, your y, which is the 4. Okay. Use the formula to find r. Okay. This is your first one. For your second one, we have 4, comma 4. Okay. Remember, make sure if you have any questions, you submit an email to me. I'll try to get to you as soon as I can. Also, make sure you submit your notes with your work, guys. Okay. All right, guys. As soon as you're done watching the video, make sure you submit your answers. And I'll be waiting for your email.